Two coil experiment. The main funda over here is to understand induction with two coils or a solenoid, not a solenoid, two solenoids. So let's see how this weird experiment helps us understand induction and everything. Actually, this is a good experiment to kind of summarize whatever we have learned till now. So let us see how so. So let me explain the circuit diagram or the structure. You have a what is this? Say a pencil or a pipe, around which we have two solenoids being constructed. One of it is connected to a battery, another is connected to a galvanometer. Right? So let us switch it on. So there will be flow of current. Well and good. The question is, what will happen to the magnetic field in the coil 1? There will be some magnetic field, is it not? That's the whole idea of solenoid. It can generate magnetic field. So basically, instead of coil 1, I'll think of it as a magnet whose strength can change. Okay, so there's a magnet whose strength can change. Now the question is, what will happen to coil 2, which had no magnetic field around it? All of a sudden, there is some magnetic field. As per the idea of electromagnetic induction, there will be some current that will flow in coil 2. Is it not? Because it's seeing a changing magnetic field, there will be flow of some current. Right? Say something like this. So the galvanometer will deflect towards the right. Okay, again, all of this is an assumption. We're not looking at exactly which direction and all of that. So it could have been, the whole thing could have been the other way around. But yes, this is only to understand the basic idea. So this coil got exposed to a changing magnetic field. So there is flow of current. So do we see flow of current throughout, all the time when the circuit is switched on? To understand that, we'll need to go to a graphical representation of the entire situation. So this is current 1 versus time. That is the current in the first circuit. And the magnetic field produced by the coil 1. Current in the second circuit. And we have galvanometer reading at the last row. So as soon as we switch on, right, current will increase. This is the circuit is still on and this is switching off. This is totally off, switching off. Like, as soon as switch off, this is where you switch off and current will gradually reduce. And this is like the circuit is altogether switched off and this is again switching on. Okay, so this is what is happening. See, this will happen in fraction of second, all of this switching on and switching off, but I'm representing it as a kind of a decent slope. So please don't get confused. It's only for understanding the concept. So this is from time t1 to 0 to t1. This is t2, t3, t4, and t5. We'll assume that. So what will happen to magnetic field between this time duration? Since you see a gradual increase in current, we know that magnetic strength will also increase gradually. We have seen all of this. And since the magnetic current strength is same, the flow of current is same, the magnetic field strength will be constant. As soon as you decrease the current, magnetic field strength also will decrease. So here it will be 0 and increase, right? This is what will happen. Now, you guys have to answer this question. In which and all case do we see changing magnetic field? Okay, so this is a changing magnetic field, right? So delta means changing, not changing, not changing, changing, not changing, changing, right? So in which time duration will there be induced current in circuit 2? Go back to the idea of electromagnetic induction. What does it tell? Whenever a conductor is exposed to a changing magnetic field. So here from 0 to T1, there is changing magnetic field. So here we'll have current flow, no current flow, current flow, no current flow, current flow. Okay, so this is what you need to understand. One small point, the current direction will be different when you switch on and when you switch off. Okay, I won't go to the detail of it, but this is something that you guys have to know. So if it this way, it'll be the opposite way when we switch off. And when you switch on again, it'll be the first initial way. Okay, again, we'll not go to the details. We'll just understand that as soon as switch off, the current is in a particular direction. As soon as you switch on and off, it will be in a different direction. Okay, so this is switching on, sorry. So as soon as you switch on, it will be in one particular direction, say towards the right. And when it's nothing is happening, it will be pointing up straight. When it's in the opposite direction, it's towards the left, no change, and it is towards the right over here. So this is how the galvanometer will read. Okay, so this is what you guys have to know. Understood? So remember, only when you have changing stuff, you have induction. That's the whole thing. Right? So you guys have to copy all of it. And also a small write-up about this galvanometer reading. When the key is inserted, there is a momentary deflection in the galvanometer, but it dies out shortly. That is, it goes back to its initial position. You saw that, right? As soon as you switch on, there is sudden increase in magnetic field. So there is some current that will be induced. After that, steady magnetic field, so no current. So the galvanometer will not deflect. That's what it reads. And when you disconnect coil 1, you will observe the needle momentarily moving, but in the opposite direction. It means now the current is flowing in the opposite direction in coil 2. So whatever we just learned, I will written it so that when you guys are reading, it will help. So now pause and write all of these points. Nothing can be missed over here.